With the development of the PyVisualize software essentially complete, I wanted to go ahead and dive into the other aspect, the other part of this project, the intelligent search. And when we talk about intelligent search, as the name would imply, we're talking about searching through a space in an efficient, economical, i.e. intelligent manner. And the best way to begin to start to wrap your mind around this problem is to think about the Indism model. The Indism model, when we were working with it before, when we were using the Java controller, we were generating all this data, but we were just blindly generating, running simulations and incrementing the parameters basically in an unintelligent way, a blind way. We're not really prejudiced on the value of the parameters or what outcome those parameters give us, you know. But that's what we're talking about doing now, because this possible space of parameter combinations that we would have to go through is very large. It's just not efficient and it's not practical and it's just not an interesting problem to solve. So one way to really begin to solve this problem is through genetic algorithms. And the method that I've come up with here that I'm going to be showing you involves a couple of things. It involves a library in Python called DEEP, which stands for Distributed Evolutionary Algorithms in Python. And it also involves a library that's going to allow us to interface with the Java virtual machine, the JVM, and that is called Py4J. Now I will explain to you in a second why this is important, but what this allows us to do is, here is some example code. It just basically declares a function, and then it declares some code that allows Python to access it from JVM. What we're going to do is we're going to run this code on the JVM, and then we're going to generate some random numbers from another Java library that we're also accessing from Python. And then we're going to call this function that we've defined here, we're going to call it again, we're going to call it in Python. So this is what it actually looks like. Very simple. All it does is generate some random numbers, add them together. Apparently not that random. And the only reason I did this is to show you, like, to get you just to start to think about what we're going to be doing here. Because what we're going to do is we're going to be replacing this code with our own Java-based NetLogo controller. So instead of calling this code, we're going to pull up our controller. We're going to pass parameters to the controller, and the controller is going to pass those parameters to NetLogo, and NetLogo is going to run the Indism simulation, and then it's going to give us whatever output we want. We're going to take that output from there, and we're going to have it here, and we're going to use it in our genetic algorithm implementation. So you can see where this is going. We're going to use Py4J as our way to interface and manipulate our NetLogo application that is running the Indism simulations. That's going to be our fitness function. It's going to be generating our fitness results, and we're going to store those with individuals that represent combinations of parameters. And then in the end, we will have bred, essentially, through the genetic algorithm, the most fit parameter based off of whatever we've selected for fitness. It could be total population, it could be, you know, any number of things. It could be a combination of parameters. I mean, not parameters, combination of outputs. You know, we could have multiple outputs. So that's why I envision this going, and I'm really just showing this to you now to sort of give you an idea of what I believe is the way forward here. And moving forward, I will be focused on actually replacing this code with the Java-based NetLogo controller, and then implementing the genetic algorithms and the fitness and finding the parameter.